So, hi, my dear friends. Yesterday, I have sent my scanned copy of the notes as well as some important questions and a list of short answer type questions along with the solutions. I request all the students to make a note of those things. Practice at least 5 to 6 questions per day. And regarding the problems on centroid, so I have already explained you about the concept of centroid, what exactly is centroid, center of gravity, and center of mass. So today I'm going to explain you the problem, right, which was already discussed in the class. That is determination of coordinates of centroid for a rectangle whose width is b and depth capital D. So for this purpose, I'm just considering a rectangle. This rectangle has got a width of capital B and a depth capital D. So for this rectangle, just I'm assuming that there is a point whose coordinates are capital C, x bar and y bar. Now this x bar and y bar, they represent the centroid for the given rectangle. Centroid for the given rectangle, where x bar and y bar, they refer to the distances from the reference x-axis and reference y-axis. Now the question is where exactly the reference x-axis and y-axis are located. Now whenever you see a problem like this one, you have to assume, the first step is you have to assume that there is a reference x-axis exactly at the bottom of the section. I'm just taking this one as reference x-axis, and let us consider that there is a reference y-axis to the extreme left side of the section. Just let us take this one as reference y-axis. Now x bar refers to the distance from reference y-axis and y bar refers to the distance from reference x-axis. Now to solve the problem, just I'm assuming that there is a horizontal elementary strip. Just I'm considering horizontal elementary strip here. This horizontal elementary strip, right, it has got a thickness of dy and it has again got its own centroid c, small x and y. The same thing again, c, x and y, where cx, this x refers to the distance from reference y-axis and y refers to the distance from the reference x-axis, small y. Okay, now I'm just considering the rectangle, I mean the strip. The width of the strip is capital B and the depth of the strip is taken as dy. If I consider capital A as the area of the entire rectangle, if I consider capital A as the area of the entire rectangle, A will be equal to B multiplied by D. If I take dA as the area of the strip, then dA will be equal to B multiplied by dy. So area of the strip, dA, it is equal to B multiplied by dy. So how did we get this one? So this is just looks like a rectangle where B is the width and dy is the thickness of the strip. Okay, now coming back to the problem, we know that capital C, the formula capital C, x bar comma y bar, it is equal to integral of x dA by integral dA and integral of y dA by integral dA, where x and y, they represent the location of the centroid for the strip small x and small y with reference to the reference x-axis and y-axis. Now as I have taken the horizontal elementary strip, when you consider horizontal elementary strip, right, you can consider y bar, which is equal to integral of y dA by integral of dA. Here y represents the distance from the reference x-axis to this point here, the C, point C. Okay, now this dA is the area of the strip which we have already derived, that is dA is equal to B multiplied by dy. So I'm writing this thing again, integral of y multiplied by b into dy by integral b dy. Now the question here is the strip, the maximum limits of the strip, I mean to say the strip can be moved from 0 up to capital B, D, from 0 to capital D. So the limits of integration will be 0 to D, 0 to D. Now the B is constant, just I'll take it outside. B integral 0 to D y into dy by integral 0 to D b outside again, dy. So this b gets cancelled here. So I can write this thing as y square by 2 by y. So it is 0 to d, and this one again 0 to d. So I can write this thing as d square by 2 by d, which can be written as d by 2. So y coordinate of centroid, which is equal to d by 2. So y coordinate of centroid is d by 2. In the similar manner, just I'm considering the same rectangle again. For the same rectangle, the reference x-axis as well as the reference y-axis are same again. Now in this case, to determine the y coordinate of centroid, already we have taken a horizontal elementary strip. Now to determine the x coordinate of centroid, just I'm considering a vertical elementary strip. This strip has got a thickness of dx and it has got a depth of d. Now the strip just looks like rectangle again with thickness dx and depth d. Same thing again, if I take dA as the area of the strip, dA will be equal to d multiplied by dx. Now we know the formula, x bar, which is equal to integral of x dA by integral dA. So here x refers to the distance of the strip from the reference y-axis, and the maximum limits of the strip which can be moved, right? It will be 0 to b. So I'm taking this one as 0 to b, x multiplied by dA refers to the area of the strip, which is d multiplied by dx by integral 0 to b d dx. dA is d dx. Now d is constant, just take it outside. D integral 0 to b x into dx by d integral 0 to b dx. So d gets cancelled again. So this is x square by 2 by x. The limits of integration are 0 to b. So I can write this thing as b square by 2 by b. So x coordinate of centroid, it is equal to b by 2. So y coordinate of centroid is d by 2 and x coordinate of centroid is d by 2. Hence proved. Thank you.